You have to do the math and you have to see like what actually makes sense. Just because something makes sense to do doesn't mean it's going to get prioritized. We deal with this all the time. You might have something that has a positive ROI, or at least projected positive ROI based upon whatever calculation you do. Okay, it's going to drive this much usage, or we're going to drive this much revenue, or whatever it is. But that doesn't mean it's got better than anything else. We could go from an hour of downtime a year to 5 minutes. Great. But we have all this other stuff to do that's actually going to move the needle. That may not actually matter. The thing you have to work on is understanding where you might break. And if and when you do break, how do you make it so that you recover faster? That's the place where most teams have a lot of room to improve, is on mean time to recovery. If this breaks, what's the quickest we could actually turn it around? Hello. Back again.
Another episode.
Another one. Tuesday, November 4th. We're getting in the high 20s. This is pretty good. That's some pretty good consistency. So not too shabby. Speaking of resiliency, of coming back when you fail, because we did miss a week. We wanted to talk this week about the concept of designing for failure and designing for resiliency from an architectural and app planning standpoint. And we'll get into it, obviously. But one of the more impactful ideas around this for me was, I think in the early 2010s, I was listening to a talk or reading an article or something like that from Jassy or Werner, I'm not sure exactly, but they were talking about the need, especially at AWS, to design for failure, right? And I think they were specifically talking about hard drives or something like that. Like, hey, your hard drives at their scale, they're always failing, right? And so you have to have a system that's designed for that failure, and you have to account for it and then deal with that. For most people, it's an afterthought, right? Like it's we built this thing, we got it out. Okay, cool. Well, maybe there's a performance testing we have to do or some resiliency, or your SRE partners are asking for your failure plan. I think what we wanted to talk about today was, how do we help teams and leaders bake that into the culture, bake that into the thinking without also going overboard? So like, you've built some pretty cool systems at large scales and financial institutions and things like that. How do you think about failovers? How do you think about building in that type of resiliency into your platform?
Yeah, well, if you're thinking about this when you're in an incident and when your customer data is all out of whack, when you are in a room with everybody looking at everybody and saying, everything's wrong, how do we fix this? That's the wrong time to start thinking about repairing and resiliency. Redundancy is probably out of the question at that point. You just got to fix things. So if you're there, I'm sorry, we can't help you with fixing your data problems. But what we can help you do is think about, how do we think about the projects overall, and where are the failure points of when systems are going to fail, when there's going to be a blip in the network, when you're going to have a queue that backs up and your downstream API can't keep up with the processing. Resiliency means a lot of things to a lot of different people, but resiliency can mean, is your service up or not? That's part of it, but resiliency can be recovering. If you're using event-driven systems, your resiliency could be, how are you reprocessing a failed message? Your resiliency can be, hey, the downstream API failed, drop it into a queue and retry it. So it starts with square one, part of your design, part of your architecture. And when you are starting to kick off a project and asking the right questions of, what's our uptime supposed to be? What is our recovery supposed to be? How fast do we need to have the data accurate for the end user? That's the right time to start asking the questions about resiliency. And that's when typically I would get in and say, okay, let's look at this. We've got some events here. We've got some APIs there. We've got some streams here. You got some file processing there. The right time is to ask, how are you going to repair that state when the data is wrong, especially when it comes to legacy systems? Now, you might have a legacy system that has 15 different writers of data to that system, and you've got null fields everywhere that shouldn't be null. It's real. I'm not judging the system. I'm kind of judging a little bit, but separately from this conversation, is that's a real state that a lot of companies are going to be in. You've got this gigantic Oracle database that has different streams coming in. And if you're going to ask, how are these nullable fields handled? Sometimes they're null, sometimes they're not, but you got to treat everything as null. But I have to know that this isn't null. Now, can't really help that, but can help you think of, well, how are you going to recover it? How are you going to backfill it? And how are you going to come up with a data contract, not just the incoming, but also the outgoing, to say, hey, look, this is wrong. Your consumers think it's going to be there. You need to either repair it, backfill it, something else along the ways. But every step of the game, it takes time to do, but it all adds up to the end when you're in an incident thinking like, oh, well, we're triaging. It's going to take you 10 times as long to triage something rather than think through some of those design principles up front and think about, how do you put that in place now versus later when your boss is looking at you and says, why didn't you design resiliency? We didn't think about it. That's the wrong answer.
You make a great point, right? Like it takes a lot of time. There's two things that are unique to complex enterprise environments. Maybe not unique, but definitely very, very kind of cogent in those environments, right? Because some of these times, like you've been around it, I've been around it, we've run teams like this, and you're like, man, this service, like I don't understand why this is so hard. I could write this in a day. And we literally did this. We had a guy like rewrite the service in a day. But the problem is the long tail, right? Like if you do it properly, to your point, there's a million little edge cases that you have to bake into your code and understand, okay, well, what if this happens? Well, what if that happens? Well, what if this happens? The other thing about these complex environments, like banks, health insurance companies, and anything that's been around for a while and has big tech and has a lot of complexity to it, is they're very interconnected. This is the thing that makes it so hard to make those major initiatives at those types of places move, is because, to your point, they don't tend to have good contract practices and discipline and things like that from a data contract standpoint.
Or they make it somebody else's problem and say like, this is the way it is, deal with it.
Yeah, exactly.
Because it's hard.
And the thing is like you could get in there, you could have a happy path of a service or an app or a flow working in a day or two, maybe. And maybe that's a little extreme, but like pretty quick. It might take you 3, 4, or 5x that to actually make it production ready. That always trips people up because they don't really kind of understand, to your point, the complexity that's going on. But we see it everywhere. Like I remember a conversation not too long ago with one of our customers. We were doing some advisory work and we were talking through, some resilience. They were in a resiliency initiative. And it was so crazy listening to them. Like to your point, it was everybody else's problem. Like they didn't realize that they needed to account for their downstream systems failing. XYZ system failed, so it's their fault. It's like, no, wait a minute. Time out.
Yes.
If your app is an atomic thing, yeah, sure. Maybe you can't complete a process if you don't have data or a downstream system, but you can't fail. You might not be able to complete what you're doing, but your app needs to work even if that other thing doesn't work. And working might be you put it in a queue, you sit it in some sort of thing you have to come back to later, you drop it off in some error flow or something like that. But like you need to properly handle that, and there's things like exponential backoffs and all these other things if you're overloading the downstream system. And I think that's something that, unless people have been well trained and well taught, that seems that they don't get automatically, especially at big companies, because you kind of focus on your little bubble. And it's like, no. Yes, it's your bubble. In some ways, you're thinking about it wrong because it's like, no. That app is entirely your responsibility. The stability and health of that app. I mean, obviously, if your infrastructure goes down, there's not a ton you can do about that. But if your downstream systems aren't functioning, like you've got to bake that in. Like that's the most basic stuff. And we see a lot of people that just don't even think about it.
It's like they consider themselves just a middleware in between that target system, and that you're integrating with the target system, not their application. And so it gets really squishy. Not to pick on those, it's just part of the culture that's been built in is that, hey, that's the vendor, that's their problem, go talk to the vendor. That's where we need to start considering applications as an atomic unit of deploying. You'd look at a vendor integration. I'm just going to say MailChimp, for example. You got an email service and you got MailChimp. MailChimp's a vendor. I'm not integrating with MailChimp. I'm integrating with your API. So if there's something wrong with your system, either report back to me or let's come up with something that is a replay system or a replay that can retry those. If, say, MailChimp is down, well, that's your problem now, not mine, and design your system around it. And that's where I've seen a lot of these conversations break down, is the delegation of responsibilities is very all over the place. And that's probably one of the number one things to set up originally is, okay, who's responsible for the failure state here? Who's responsible for the failure state there? I can't always retry something to your application if your vendor's down. That's something that should be built into your system because you've got the integration with the vendor, not me. There's two parts that I've seen break down often. First, it's the delegation of responsibility or the I don't want to do it. Or it's the other part is I don't have time. Or it's the thought of I don't have time. You do. Either you're going to spend the time on triaging, you're going to spend the time on fixing your repairs, or you're going to spend a quarter of that time with building it right up front. That's a hard conversation to have with your business partners or the product team, is saying that, hey, you know what? I need to build this in because we're going to be spending more time later with triage and incidents and repairs and customer dissatisfaction than if I just need that more time up front. Nobody's going to say no to that. Nobody's going to push back on that.
Not if you can articulate
not a single person.
No, but not if you can articulate it, because it's like, oh yeah, you're right. Usually what happens is people just don't think about it. And nobody thinks about it. So a choice is made by omission, but not by commission. Nobody's intentionally saying, oh, I don't care about resiliency. We're just going to skip that. It's like nobody brings it up. And so nobody really thinks about it. Yeah. And well, because the business doesn't know, like, unless, I mean, some of the I've seen business partners in some of these, like I remember a guy I worked with at Bank of America in the home loans business space. Like he knew home loans inside and out. Like he was a product manager, but he had come from sort of the business ops place or part of the bank. And so he knew in and out all the different flows. And so he was actually the knowledge base of like how the logic flows should work. That was an unusual situation where he was actually bringing, because of his understanding of the processes, even if he didn't necessarily understand the underlying technology, he understood where things break down and how to like plan for that. But that's not the norm. The norm is
that is rare.
Yeah. Yeah. The norm is I want my stuff. I want it as quick as possible. My big shiny thing. How long is it going to take?
Or this is when I need it.
Yeah, exactly. Well, yeah. Yes. You have to develop that muscle, right? Like I think I've said it on here before. One of the more interesting conversations I had, I remember with a guy that was an InfoSec leader. He was like a cloud security leader at a bank. And I was just asking him like, hey, I've been around, like been in the tech world for a while, all these different things. Like, what's the big difference between a security engineer and a software engineer? How do you look at it? Because he had guys that were working for him. And it was like, is it different skills? Is it different education? Is it different like brain power? Like, what is it? And his response was like, obviously you have your like very elite people, just like you do on the development side. But by and large, a security engineer, quote unquote hacker or preventative or whatever it is, they're just focusing on it. It's just software development, but they are putting attention on it. And so, one of the things that we were doing in that particular thing was they wanted to build this concept of a security champion, which was essentially trying to embed more security engineering practices into the SDLC and get developers thinking about defensive security practices. This is the same kind of thing. SRE doesn't necessarily do all the work. They consult and help you think about the right problem to solve, right?
They're advising most of the time to say, this is what you should be thinking about in your design and auditing a design.
Exactly.
So you're trying to encourage those individuals to put those resiliency in their designs up front so that they're going to be the ones getting on the call. Yeah. They don't want to do that.
It's like QA, right? Think about like a good QA engineer in today's day and age, right? The manual QA where you bang on, click through all the things and do all that stuff, like that's shrinking and shrinking and shrinking, right? It's becoming just a coding exercise, but it's not just a coding exercise because
it's intentionality.
It's a skill. There's a skill and intentionality to thinking through all the negative scenarios, right? Like there's the positive scenarios everybody knows, but like the negative scenarios, okay, I'm going to create some corner case because I'm going to do like these 7 different things in this sequence and boom, I create a problem or I find a latent problem, right? That's what the really good, and we've worked with some, right? Like the really good QA engineers just find the problems because they know how to look for them, right? Like they have these
they know they've got the rails in their head. They're just always looking for problems or looking for the common scenarios, looking for what happens if the joke is, the developer goes in the bar and orders a beer and he gets a beer. A QA engineer goes into a bar and orders a grasshopper and the bar blows up. They just know which grasshoppers to ask for and when, because they've done it all the time. They've done it often enough and they've picked the wrong scenario enough. And it's that common patterns that they have built. So it's an expertise, but they could push that expertise into the other teams by saying, hey, this is what you should think of, but based off of my experience.
It's very relevant to the resiliency stuff, right? What are some of the questions or things like habits we want to help people establish? Like the thing I would say is like at every step of the way, take a step back and say, okay, how can this break? Like what are the places that this could break? Where are the weak points? Like an architect or an engineer would look at a bridge. They're going to look, okay, where are the stress points? Where are things likely going to break? And we've done this, right? Like people that are app leaders and architects that have been around, like you always kind of instinctually know where the places things are likely to break. One, because that's where it always breaks and you have history with that particular system. Like, for example, there was an authentication flow at one of the banks that was very complicated. It was stitching together a bunch of different things. It was a little fragile and also off is hard at an enterprise scale. The assumption was, okay, if anything even remotely close to that is broken, it's probably there, right? Which is maybe unfair to that team, but that was like the assumption because it was the most fragile inherently, right? And so you start to understand some of those things, but then you look at the architectural diagram and you can start to understand that, right? Like, okay, what service is calling what? What's multi-region, multi-AZ, multi-service? What's got a lot of different dependencies? The more dependencies you have, the more surface area there is to break.
And the short answer is everything fails. Everything will fail at some point or another. I think it's how often this is going to fail because you do have some diminishing returns if you have a hyperscale downstream API that you've got the experience with, as you're mentioning, it typically doesn't ever fail. Maybe it's got 4 nines of resiliency. It's got the history of it. So is your time well spent with designing a robust resiliency pattern for calling that? I don't know. I probably wouldn't focus there. I would focus on more of your data's resiliency of what happens when these error states are in the data, or there's missing fields that should be there that they're not, or to those other endpoints or APIs that you're calling that maybe have a spotty track record of success.
I can think of one thing in particular. This was at a banking environment, and it had to do with the deposits, the money movement fraud flow. You go in and you either put like an ACH or wire transfer or something like that in, and obviously you submit that through your app or on the phone or in the website or whatever. And then that's a request. Like the money doesn't move instantly usually, right? And so then that drops it into a queue, and then it kind of goes through a bunch of anti-fraud systems. And I remember these guys in particular had a situation where they were calling out to this vendor, one of the credit bureaus or something like that, had a fraud data source thing. So they would basically have the data that they have, and they say, okay, hey, based on the data I have, enrich my data with additional fraud signals that I can then pass to my decisioning engine. That had a pretty steady amount of traffic or whatever it was. And it was good because they had a bunch of queues. They were using Kafka, but they had a bunch of queues that if it didn't work, it would get dropped in the queue. So they had some resiliency built into the system. So it was failure. I don't know what the right word is, but it could handle failure, right? But what happened to them was the vendor that they were calling went down or got backed up or really slow.
They were backed up really slow. Yeah, that's what it was. Yes.
Yeah. It took it went from a normally to like a 500 millisecond per call to like 5 or 6 seconds per call.
Yeah, it was
and
bad.
They could only make so many at a time. And so then what ended up happening was the queue just grew and 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 grew. That lasted for a few hours. But then what happened, which was very interesting, in retrospect, it sucked at the time because I was up for days dealing with trying to solve for this problem. We did all kinds of creative things that we won't go into now. But what happened was, because of the way that our infrastructure and Kafka things were configured together, we had a max throughput that we could actually handle, which was fine in most cases, right? Like it was probably 1.5 times our normal peak. And so it was fine. But once we had 50x that or 100x that or whatever, thousands of things in the queue when we could only process through, I'm making up the numbers, but like say 5 a second. And we were also getting in an additional 2 or 3 a second, right? We were burning down very, very, very slowly. And it took days very long to get caught up. Queue. It was brutal. It was brutal. And there wasn't anything we could do. There was all kinds of partitioning, and Kafka wasn't really our specialty at that company. And so we didn't really know how to use it as effectively as we could have. I could have killed for a Lambda, but with SQS and a Lambda, just fan that out and be done with it. But that unfortunately wasn't an option on the short term. We did end up doing that with, I think, your help, actually.
Yeah, I was part of designing that out. And that was, it was a great design because, it was a little bit too late at that point in time.
Yeah, it was. We couldn't just cut it over. We couldn't feed the Kafka feed into the Lambdas, unfortunately. But the point of bringing up that story is just, that's what happens. These things, you have a good design, but you don't think through the one choke point, right? Or you don't realize that there's a checklist of things you can go through. It's like, okay, hey, what's our scale point here? What are our options for scaling up, scaling down, scaling out? If we do need to recover, because to your point, we've seen it just in the last few weeks, right? AWS just had their kind of every 18-month US East 1 outage. Azure then had one the next week. I like to make fun of Microsoft for always trying to copy everybody else's innovation. For some reason, they think the outages was part of the innovation. Like, you didn't have to do that, guys. But we've seen it, like when AWS has these big outages, the outage is bad for sure. But the recovery takes hours. And sometimes it's longer than the outage, right? I remember a few years ago when one happened, one of the things that had happened was Fargate was completely screwed up. And I hope I get the facts right, but this is how I remember it in my head. But Fargate was completely hosed. And so what ended up happening was, like, all these Fargate tasks had shut down. And so in the underlying infrastructure management, basically Fargate had released back all these EC2 instances back to, the EC2 service because they didn't need it. Like, the Fargate service didn't need it. They always keep a certain amount of headroom in their compute needs, and then they could spit out more if they need it. But what ended up happening was they went down to say 10% of their typical workload because it just automatically spun down because there were no tasks running. And then everything started working again. But the underlying, okay, I need to provision more hardware into Fargate so the Fargate can then pass it on to the user. Like they hadn't accounted for that. And so it took hours and hours for the underlying EC2 instances to get provisioned back up into Fargate and stuff like that. I mean, that's the hyperscalers have different problems than the rest of us. And so unless you work at one of those places or one of the, what do they call them? The neoscalers or something like that, the neo cloud companies, unless you're dealing with that type of infrastructure load, it's a totally different ballgame. Generally speaking, I think it's for us, and for the type of people we work with, it's more of an app issue.
It's the fail states within the apps. It's the, how are you doing your retries? The retries themselves, as long as if you start putting some dead letter queues in, come on, this isn't hard. You're putting a queue, put a dead letter queue in. It's part of the checks, part of your production readiness guidelines is dead letter queues. It's not hard. It's pretty easy. Couple lines of CloudFormation, it's done. But then it's the API retries. Well, what happens when this does? Because you could have a flow that's 3 API calls deep. One of those fails. Do you really want to have your customer resubmit the entire flow? If it's asynchronous, you want to have everybody bubble up those errors? Or do you want to take that, put it into a queue and retry later and maybe inform the customer that something failed? I'd rather the latter because it's a better customer experience to know like, hey, I got your request. I'm taking care of it. We'll let you know if there's a problem. And
that's a really good point. Like you handle synchronous and asynchronous problems very differently. Synchronous is what we usually think of. Oh, the website's up or not. Like if somebody tries to, let's say, go onto a dashboard and load their account balances, right? Like if that fails, your window to accomplish the task is finite versus something like what you're talking about, what I was just talking about with like a fraud flow. They've kicked off the process. You have to bring that process to completion and, sort through that. And the complexity of those go way up.
And there's 2 different states there. One is the data is wrong. And that's never going to finish. That's something that needs to be treated differently. Then you've got the data is correct, it validated. There's an underlying system problem that we will retry and it will work eventually, but it's just down right now. That's something that is, again, it's a distinct scenario that should be handled. Like, hey, we got it. It will process. Don't worry about it. The other one, you have to handle maybe a little bit more real time to know the data is wrong. We won't be able to process this. Retry right now. It's just having the discussions, having the, how do you know what's going to happen unless you start doing a deep dive into your systems to know what are the scenarios that I need to handle? What are those problems that I'm going to see? Where are we going to see that maybe I have a default date that was in 1970, probably not accurate, but if it's sent to a different system, they're going to trust you that that's a correct date. Validate on the way out. A null field is better than a wrong field most of the times. But those are the things you have to think about and do an audit on of, am I ready for this? Do we need to do some more data cleanup? Do we need to do some just-in-time handling of these weird scenarios? Or, hey, before the customer submits, do a last-minute check to say, hey, is this going to pass muster the rest of the systems because I have a contract that I've got to abide by on the events? Not just an API contract anymore, but it's an event contract too. So if it validates on the way out, you're good. If it doesn't validate, error to the customer, let them know there's something wrong. We need to repair your information. It's hard to think about those things when you're designing and architecting these flows, is that you don't know until you do some research and spend more time. But oftentimes, I'd say most of the time, it's worth doing those checks.
You mentioned something, I think last week or the week before or some other time, that you got to do the math, right? And I think on some of these conversations and some of the math, like kind of back of the envelope math is really kind of straightforward, right? What industry are you in matters, right? Like if you're in e-commerce or something like that, a failed customer interaction might directly translate to dollars, right? Like it might be lost revenue, all those different things. Like I think you have to get a profile of your business within the banking industry, for example, which is where we have a lot of experience. It's not necessarily lost dollars. It's more consumer confidence and also regulatory issues, right? Like if you have enough problems, the regulators are like, what's going on? And that's lost dollars. There are a few things that cost banks more money than getting in trouble with regulators on operational or technical issues. Incredibly expensive time sucks to deal with, right? It's more defensive in that respect in the banking world. If you had a loan flow, like an application flow that was down, yeah, I mean, like maybe somebody,
it's a big deal.
It's between Chase and Bank of America, and Bank of America's app is broken. Well, maybe I'll just go do Chase because I can't be bothered, right? Like, so you do lose revenue, and that's canceled. But I think that's a good place to start. You don't have to do this really for every application.
Even like what flow it is. What flow are we? Just kind of you mentioned the loan flow. That's a pretty critical flow. So you might want to spend some time on resiliency. But if it's a very simple flow that is not critical to making an order or creating
change
a loan,
your marketing preferences.
Change your marketing preferences. Fine. But that's actually one you got to be careful of too sometimes, because there are some regulations around opting out of email communications, and then you're like, oh wait, I didn't actually.
Fine.
And then the customer has a way to talk to the regulators themselves and say, hey, look, I opted out, but I'm still getting spammed. I've been on those calls. Not my app, but another app. So
No, for
it's
sure.
a real thing.
I think that's the point, right? Like you start meta a little bit. I mean, you should have a rendering with your organization in terms of like, what kind of business are you in? How mission critical is your business, right? How mission critical is your application, your tech? I would say relative, like if you're, top 5 banks, online banking flow, that's a pretty critical to the economy system, right? Like, because people can't get to their bank accounts, that's a problem. And it runs on banks and stuff happen because of things like that. Like I remember back in the day, I mean, it's kind of a chicken and an egg, right? Silicon Valley Bank was having some trouble and so many people were trying to wire money out that their app crashed, which made it way worse. Maybe that just meant that maybe they did it on purpose, kicked the plug out of the socket to just stop the bleeding. But yeah, I mean, it's not good. It's not good from a confidence standpoint.
GameStop stuff too. Like when the GameStop was going on fire and then people are all trading and then you take down the trading systems, nothing else can be traded because all the systems are down. It can be a real problem. And tax day seems a little bit simple, but everybody's logging into their bank at the same time and trying to check the balances, which could in turn take down something else that doesn't go down, but this one did because it's just not scaling properly.
Yeah. So I think you start with, you have to have an understanding of your business, understand how it makes money, understand how it loses money, understand what the risks are, right? Like what kind of tolerance do you have for outages, right? Like, are you a marketing data company? If you're a marketing data company and you lose some data, like it's not the end of the world, right? I mean, we're going to get messaged now and be like, you don't know what you're talking about. Like, fair enough. But like, I'm sure there are apps out there that if you're down for a minute or two, it's not the end of the world. If you drop some data or whatever, it's not that big a deal. Obviously, nobody wants to do that. There's professional pride, there's customer service, all those things. If the metal meets the road, you really like sparks are flying, right? Yeah. So, but I mean, from that standpoint, like you got to understand that. And then it gets down to your point, to the individual flow. And it's like, okay, well, what's our tolerance here? Because like we did this at a bank, right? Like we had some stuff that was slated for multi-region because we wanted to make sure that that particular customer journey was as resilient as we could make it within reason, right? We had data replicating, we had all these cool DNS things that would flip it back and forth and all that stuff. A lot of the backing systems, like all the other stuff downstream, there's all kinds of stuff that we never went to that degree with because it didn't necessarily make sense, right? Like we could be in a degraded state and it was quote unquote good enough for a period of time. It wasn't worth the investment to make the entire banking stack tip to tail multi-region because that would have been just
multiple millions of dollars over multiple years. And then you could get halfway there for a small fraction of that and you're still good enough for now.
Yeah. So you have to, I mean, I think that's part of the architectural. I mean, it's one of the reasons like functions like enterprise architecture exist is sort of help work through that with the business, with the technology teams and say, okay, let's do the math on what matters here. What do we really need to have? We always talk about 3 nines, 4 nines, 5 nines, all that type of stuff. I think those numbers are thrown around a little bit too casually, personally, because I've never seen a system that actually achieves 4 nines, right? Like it's not realistic. And nobody really needs that, right? Like, which just not really what you need.
If you do the math on it, it's minutes a year that it could be down. But also, like, there's a lot more context in that because it's just being down in the middle of the night really matters sometimes? Probably not.
Yeah.
And, during the day, it's the timing of that.
I used to make fun. It was funny. I happenstance was at a conference 2 weeks ago now. The CIO of a business line I used to make fun of. I love the guy. It was a great company and he's one of my favorite leaders, but I used to tease him because they would take their system offline every night. Like every night they would just go, we're going to turn off access at 2 a.m. or whenever it was, do all their batch processing for the day and turn it back on before everybody on the East Coast woke up. Like I said, I always made fun of that because it feels very like 1994, but it's perfectly valid from a business standpoint. We could put the effort in to make it as resilient as we want and make it zero downtime batch and all these different things, but they don't really care. Like it doesn't impact their business. Fundamentally, they're not writing loans. They're not writing loans in the middle of the night. Who cares, right? So that was sort of their perspective. I still don't fully agree. Like it kind of pains my soul, but at the same time, like to your point, you have to do the math and you have to see like what actually makes sense. And also just because something makes sense to do doesn't mean it's going to get prioritized, right? Like there's a lot of stuff, we deal with this all the time, right? Like you might have something that has a positive ROI or at least projected positive ROI based upon whatever calculation you do. Like, hey, it's going to drive this much usage or we're going to drive this much revenue or whatever it is. But that doesn't mean it's got better than anything else, right? So you might have a lot of stuff that'd be like, we could go from an hour of downtime, a year to 5 minutes. And it would say this, like, great, but we have all this other stuff to do that's actually going to move the needle. That may not actually matter. But I think bringing it back to what you said, I think the thing you have to work on is understanding where you might break. And if and when you do break, how do you make it so that you recover faster? That's the place where most teams have a lot of room to improve, is on mean time to recovery. We had this happen. We had these really cool pipelines, like these really, really, really amazing pipelines that did everything. I was on a triage once and I'm watching this team know exactly what the problem is. They had just broken production. They knew exactly what the problem was. They made the code change in about 2 minutes, and it took, 37 minutes to get it into production?
Yes.
And I was just beside myself. I was just like, what? We've lost the plot. And it was not that hard of a fix. Like, we just needed a break fix process, basically. But because we built this nice, rich DevSecOps pipeline that does all of these things, which is great, except when you have a Seb 1 issue going on and your system's dead and you need a one-line change to go in, and now you have to wait 37 minutes. What the hell are you doing, right? And so you have to think through those things and understand, like, okay, if this breaks, what's the quickest we could actually turn it around, right? Like, what's our SLA on a breakage? What's our, all those different things, and really focus on that stuff. But I mean, you're the one that actually fixed that problem.
It was a long time ago, but I do remember, yes. What we did, I don't remember. There's some very smart people who are building those pipelines.
I would say, as you're looking at how do you reduce your breakage and your time, your duration of incident or duration of problem, you can really, deployment strategies are a great way to sort of leverage that, because most problems happen during change, right? Like, that's not really what we've been talking about this other time, because we mostly been talking about like resiliency around like edge cases or downstream problems and things like that. But most incidents happen because of someone's change, right? Having good rollbacks, ideally fully automated, blue-green style. We tried Canary for a long time. Really kind of blue-green is better because it really gives you an instant rollback and things like that. But we can, like you said, we'll save that for another time. But if you had somebody asking you, what do I need to do to make sure that my app is resilient? What's the checklist?
Checklists, queues, APIs, asking the right questions in the beginning. In reverse order here, because it's asking the right questions is probably the most fundamental thing that you can do, is kicking off a project. What are my targets here? What should I be doing? Making sure that you have the full list of things that matter. Not necessarily the mechanisms yet, but what outcomes are we looking for? And that's, I think, where this whole thing would break down, is not asking the right questions up front. What should I be designing for? And that if you don't do that, then the rest of it doesn't matter, because you could be designing systems that never get called because you've over-engineered something, or you've under-engineered because you didn't ask the right question. So ask questions. That's the first thing. And just build a checklist. Do you have a resiliency checklist? Start building that. Because there's all these different scenarios that you could have. But if you don't build your checklist, you don't build your, do I have this? Do I have this? How many queues do I have? Are they monitored? The rest of it doesn't matter. You just have to take inventory of what you have and make sure you build your plan around that. And make sure that you're marking the things that have dead letter queues, making sure you build the retry mechanisms, your backups, your strategies around that. That is probably the most important thing. The mechanisms aside, most important thing is having your inventory and doing an audit against that.
Yeah, no, I agree with that. I think that's right. It's actually not usually that hard if you're asking the right questions, right? No. Like it's the failure is the failure to examine and ask the questions usually. So yeah, no, I get it. It's good. Awesome. Anything else, Dad? You good?
No, I mean, if anybody else has anything that they've done, something interesting, an interesting tidbit that they built into a system, drop us a note, drop a comment in here, send us an email. We'd love to have it, to discuss it and take a look, learn something new.
Absolutely. All right. Well, thanks for the time. We'll get back to work. Hope everybody has a great rest of the week. Take care.
See ya.